Hi guys, how are you? In this video we are going to learn how you can deploy your deep learning model onto a Android app by using the Kotlin language. This time we are going to do with Kotlin. And yes, I know we have already done so many videos about deployment of the model on the Android app, but still you guys are just every day I'm getting new comment on a video. My app is getting crashed while I press on the predict button and so on. Like there are so many similar errors you guys are getting, and in this video I'll try to resolve all those errors, and also I will make sure that you do not get any error in future. I would recommend you to watch this video completely, and when you are totally free, just don't put the video on 2x and just start watching and skipping the parts in between. Just don't do it. Then it will going to create more errors. So that's only the recommendation, and I'm going to cover this video in few steps. The first step would be to have the TF Lite model. So what actually happens when when you train your model, it is usually in .h5 format. So first we need to convert our model into the .tflite model. Once we have the model, we will create a new Android app, and we are going to take that tflite model, build the UI, build the backend, then import the model and just do the prediction. So for this particular video we are going to use resnet 50 model, which will going to take input as the image and will going to output the prediction of 1,000 different classes. So I hope you have basic understanding of Python and deep learning models. Actually should have, since you are watching this video for model deployment. And I have this VS code opened over here. I'll just not confuse you right now. Just to make you clear, I'm going to convert this resnet 50.h5 model into the tflite model, since the first step is to have the .tflite model which we are going to deploy. So first of all, I have opened this VS code in the same directory, and I'm going to write a script convert.py. So first of all, we are going to use TensorFlow, and TensorFlow has a library to convert .h5 format into .tflite format. So you'll see how easy is that. So first of all, we are going to import TensorFlow as tf, and also you need to import actually from keras models import. Okay, so first of all we are going to import the model by using load model, and the name of the model is resnet 50.h5, which is this one, resnet 50.h5. Now once we have this model, we are going to create a object of converter which is inside tf.lite.tflite converter, and in this there is a dot from keras model, and in this you have to pass your model which we have just loaded. Okay, which we have just loaded over here. Now once we have this converter, we are going to call function converter dot convert, and this is going to return our light model. Let's just call this light model. Now once you run this, we are going to have light model, but we need to save it in locally. So for saving, we are going to use the basic functionality with open, let's just call this light model.tflite. Let's open write binary as f, and we are going to say f.write this light model. That's it. Now if you run this script as it is going to create a new .tflite model in the same directory. So to run that, you have to say python convert.py like that, and it's going to take a while, about 6 to 7 or about 10 seconds depending on the speed, and you should have .tflite in the same directory. So let's just wait for time. Okay, so finally we have light underscore model.tflite, and but the problem here, you see that it is of 102 megabyte, and it is a lot. This whole 102 should fit in the Android phone's memory, so that might not be a problem. It can run fine, but we need to reduce this size as much as possible. So for that we have something called converter, which you can specify converter dot optimizations, and you can pass it as the array. And for optimization you can say tf.lite dot I guess optimization, if I'm not wrong, optimizations dot default. You can pass it like this, and if we try to run this, and hopefully it should run if we do not get any error. Okay, we have error has actually it's optimize, not optimizations. So we'll just say tf.lite.optimize.default. Now it should run. Okay, no errors. Now again it is going to take some time, but this time the size should be reduced from at least 102. It should be half at least, my guess is there. Other than that default, you can also provide optimize for latency, optimize for size, optimize for experimental sparsity. You can try it on your own, but for me this default works fine. If you want, I will also link this page in down description. You can just check this out. All right, it is completed, and now guys, see the size. It is 26.2 megabyte, and accuracy might be, I don't actually know, but I tested it. For me the accuracy didn't change. The predictions are still the same, but the size is reduced a lot. Now we have the .tflite format model. Now let's move to the next step. Let's create a new Android Studio project. So I would recommend you to go on with me. Just open your Android Studio now. It's the time. I'll just close this VS Code. This code will be in down description, don't worry about that. I'll also close the terminal. I'll close this, and let's create a new project. And this time for this video I'm going to use Kotlin language. I have already created so many videos with Java language. There are hardly about one video with Kotlin language, I guess. So let's create a empty activity, and let's call our, let's say, resonant app. Let's call it resonant app, and the language I'm going to use Kotlin. Let's hit finish, and we are going to wait for some time for letting it finish its work. Okay, so while it is loading up, previously I have told you how you can convert your model into .tflite format model. Now this model which I am using is .h5 format, and this takes the input image as BGR format, and it is not the RGB format, and it is very hard to convert the color space of the bitmap from RGB to BGR. The ways you can use is by using OpenCV, which is already ongoing series on my YouTube channel. So we can do that by using OpenCV, but that is going to increase the size of the app. So for this video only, I just told you how you can convert your model into .tflite model. And while you are training your model, make sure you just train your model with the data of the images as RGB format, since it will be a bit harder for you to convert the bitmap into the BGR format color space. At least for now. I tried searching on Google. It is quite bit tricky code. You have to go with that. So for this video I'm going to use let me just take you to there. So for this video I'm going to use this image classification which they provide is download starter model, v11 model. This model I'm going to use. All right, now our model Android app is created. So let's create our UI. I'm going to keep the UI very simple as possible. So we are going to use relative layout, and we will going to have a image view, and then two buttons, and then the text view for showing the predictions. So let's do the same. Let's have the image view, and the width will be, actually let's just say match parent, and let's give the height of 500 dp. Let's give the background just to see what is going on. Let's give the ID, let's say it is image view. I guess that's enough. Now let's create two buttons and one text view to show the result. So buttons will be in linear layout. Let's say width is match parent, height is wrap content. Let's give ID lin layout, and it will be below of our image view. So the width will be wrap content. Let's give the text as let's say select image, and let's give id select ptn. I guess that's enough. Let's copy this same button, and the text will be predict, and the button id will be predict button. Let's center this horizontal to nope. Let's set width to wrap content. Done. And then finally we are going to have our text view to show the prediction. It will be wrap content. Let's give id as result view, and let's give text as prediction, and it will be below of our linear layout. That's all. We can give font size a bit. Text size, let's give let's say 20 dp. How much is it? It's fine. Let's give margin left just a little bit, 10 dp. That's it. And let's give the margin right to this button, let's say 10 dp. Alright, finish. This is our UI. If you want to change it, just go on with it. I've just kept it simple as I could. Alright, so here we are in our backend. Main game will going to begin over here. First of all, we are going to initialize our buttons. So there will be a select button of type button. Then we will have a predict button of type button. Let's import it, option enter, and we'll have a view also. So it will be a text view, and then we'll have finally our image view. That's it. Let's initialize them in our on create. So there is a select button equal to find view by id r.id.select button. Let's do the same 4 times. We have a predict button, we have a predict, then we have a result view, then finally image view and image view. Okay, now when this select button is pressed, we want to open the gallery, and the user will going to have to select the image. So when this image has been selected, we are going to show that image inside this image view. Let's do that thing now. So we have a select button dot set on click listener. So when this button is pressed, we want to create a new intent which will going to open gallery, allowing us to open the select the image. So let's create a var intent of intent equal to intent. Let's import it, option enter, and intent dot set action. It will be action get content. So it is intent dot action get content, and intent dot type set type. Now the type of data it is going to access, it is image type, so any type of image. Now we are going to start activity, simple start activity for result. Since we need the result from the activity, whatever the image is selected, we want to access that data. So we are going to pass the intent and then the code. Let's give the 100 code. You can give it anything. Finally, inside this class, outside of this function, we are going to override a function. You are going to see on activity result. That's it. Now we are going to check if this request code is 100, which we have passed over here. So if request code is equal to 100, we are going to access the URI first of all. So it is data dot okay, so we are going to say URI is equal to data dot data, and it can be null, so we are going to give it question mark. Now we have this URI. We are going to this is uniform resource indicator, I guess. So from this location we are going to read the image. So the image which we are going to read, I'm going to store it inside this bitmap, since we are going to use this later on when the predict button is pressed. So let's import the library. So we are going to say bitmap is equal to media, I guess. Yeah, so you can say media store dot images dot media dot, yeah, it's get bitmap. So you can just pass this content resolver, so you can say this dot content resolver and pass this URI. Once we have the bitmap, I'm going to say image view dot set image bitmap, and let's just set this bitmap like this. Everything looks fine over here until now. Let's try to run this app up till over here, and let's see if we get any error until now or not. Alright, so emulator is loaded. So when I press the select image button, gallery should be open and I should be able to select the image, and the image should be on the screen. That's it. Everything is working totally fine as expected. Alright, now the main part, which is what should happen when the predict button is pressed. When the predict button is pressed, we are going to use this bitmap and we are going to send it for the prediction to our model and then get the output from the model. So first of all, we need our model. So for importing your model inside your app, we are going to click on file, new, and other, and TensorFlow model. Now you need to locate your model wherever it is and just hit open and hit finish, and it is going to take a while to install the TensorFlow Lite library for your device, and finally you should have this sample code. So we are going to just copy this sample code. If you are doing this with Java, you should have to click on this Java, and here is the Java sample code. Okay, here. Now what we are going to say, predict button dot set on click listener. So when predict button is pressed, we are going to load this model. Let's just get rid of this. Let's import this, option enter, and for context you need to pass this tensor buffer. Let's option enter, data type, option enter, and this byte buffer we need to resolve it. Just wait a bit. Alright, so here is our model imported. Now we need to pass our image over here, but we cannot pass our image as it is. For having our bitmap into the byte buffer, we need to follow these steps. So you need to create a tensor image like this. So you can just say tensor image, and in this tensor image you can pass the data type, which is uint8 for our model. You can see over here like data type dot uint8. So you have to just pass it like this. So data type dot uint8. Now once you have your tensor image, we are going to say tensor image dot load, and you need to pass your bitmap over here. Which bitmap? This bitmap which we have selected by pressing the select button, right? Now from this tensor image we can get the byte buffer like this, tensor image dot buffer. Just get it like this. Now if you run your app like this, your app is going to crash for sure. Why? Because the size of the image, we need to convert our image to 224 by 224 pixels, but your image could be of any size. So for that we are going to use ImageProcessor, which is again provided by TensorFlow Lite. So for that we are going to say, let's create ImageProcessor, where ImageProcessor dot builder dot add. Now when you hit dot add, you have to pass the image operator. They call it image operator. So they have a resize operator which can resize the bitmap into the particular size you want. So you have to give 224 height, 224 width, and then the resize method. So you can say resize method dot bilinear. Let's give bilinear, and then finally you can say dot build. Finally, to use this image processor, what you have to do, image processor dot process, and it expect input to be as tensor image. So here we have tensor image, and it is going to return the tensor image like this. Okay, so if you run your app like this, it should run no problem, nothing will going to occur. Now one point I would like to raise at this point over here. Okay, it is totally fine that our current model is using the RGB format image. Maybe your custom model would expect the image to be in grayscale format. So how do you convert the RGB image into the grayscale format? Luckily for us, TensorFlow Lite have a normalized TensorFlow has a normalized OP for us. Here is TensorFlow has normalized OP, and you can pass it like this, and you can give 0.0 f and 255.0 f like this. So what this is going to do is normalize your pixels from 0 to 1 if you are using normalization. And if you want the grayscale OP, again here we have a grayscale OP, but for this default version which this automatically loaded in our Gradle script, let me just show you 0.1.0. So alright, so the version you are going to use is 0.3.1 actually, and you can hit sync now. So after downloading this version, you are going to have a grayscale OP also. So dot add transform. So now you have transformed to grayscale OP also after using this 0.3.1 version. So this is how you can use ImageProcessor to normalize your image from 0 to 1 if you are using normalization, and you can use transform to grayscale OP for converting your RGB image to grayscale. But for our case, we are not going to use it since our model do not expect our image to be in that format. Okay, so now the last step is this is the output features, which is the output from our the model. So you can just get float array from it, get float array. Now from this float array, we need to get the index with the highest value. So we can just write very simple loop for that. You can say output features 0 dot for each indexed, this one. Now we have the index and the value, so we can say output features 0 maximum idx is greater than current value, sorry, smaller than current value. We can say maximum idx equal to index. That's it. Now finally we can say result view dot set text and maximum index dot toast. The problem with this is that it is going to give us the index. We need to convert this index into the particular label, whatever label it is. So with the model which you are going to download, they are also going to provide you labels. So I'm going to just rename it to labels.txt. So it is going to provide you labels of all the 1000 categories. So whatever index we get as the maximum index, we are just going to use the labels. So for that we need to import our labels.txt into our Android app, and the location where you need to import should be inside the app. You need to create a new directory. Let's call this directory assets. If it do not show, like in my case it is also not showing, you can click on project, and inside your ResNet, inside your app, here we have the assets. Let's paste our labels.txt over here. That's it. We have our assets labels.txt, and inside your main activity.kt, you need to read this labels.txt. So for reading, again, it is so easy. In Kotlin you can just say labels equal to application.assets.open and give the file name, which is labels.txt dot buffered reader, and then finally you can say read lines, and it is going to return you let me just show you if you didn't pay attention to it. So read lines is going to return you list of strings. So every line will be split at /, and every new line will be a new, with a new index. So here is our labels, and finally when we are saying result view dot set text, instead of index we are going to say labels with the max index. That's it. This is it for our whole app. Let's try to run it and see if it works fine or not. I guess our app is crashed. Let's just try it once again. Yeah, so for resolving you need to at least get the error, at least what is the error. So for getting the error, you can click on run over here. Now you should have the error, like what actually caused this error to be happen. In our case, it is unable to start activity, file not found exception, which is labels.txt. Okay, it says that labels.txt file not found. Alright guys, actually the error occurred because you need to create the assets folder inside this directory, source main then assets. So our problem was we have created the assets folder inside this app, but you need to create the assets folder inside source and then main, and here should be the assets folder. So let's try this once again. Let's try to run our app once again and see if still there is error. Okay, there is no error, no crash, error is gone. You need to put the assets folder inside source main assets. Just make sure you do that. Let's try to select the image apple and click on predict. It says Granny Smith. It's a green apple, sour apple, which is called Granny Smith. Okay, it is apple probably. Let's try to select this dog. It says golden retriever, fine. Let's try to select this banana. It says banana. Let's try to select this apple. It says pomegranate. Yeah, it looks like kind of. Let's try to select this cat. It says Egyptian cat. Okay, we are not getting any error, but still if you guys still are getting any error, just try to watch the video once again and see if the error can be resolved. Still, if you have any error, you can put that error in down comment section. You can get what the error is by just clicking on this run button, what actually the problem which caused that app to crash. Still, if there are any error, the most of the chances which I think is the cause of error is this data type mismatch. So probably here could be float 32 and you might be using uint 8, that is going to create a byte buffer error. So you can just check that out over here. Still, if there are any error, you can ask them in down comment section. We have our model loaded and the predictions are being done fine. There are no problems. This is it for this video. I will just end this video over here and I'll catch you in the new video. Till then, goodbye.